I hope you had a good couple of days, and I hope you are ready to continue with Inkscape, because that is exactly what we are going to be doing today. This should be the last day that we use Inkscape in a classroom setting, and then next week we'll move on to something new. So to that end, I'm going to spend some time introducing a project for you guys, and then maybe we'll spend the last 15 to 30 minutes getting started on it. And then I would encourage you guys to spend some time working on it, because it actually relates back to the lab that you guys will be doing, a lab that you guys will be doing in the next week or so. But yeah, so, this whole time we've been focusing on how you can use vector graphics, how you can convert things to vector graphics, why you might want to use vector graphics, all that kind of stuff, including the sort of the pros and cons of each. But we've skipped out on one pretty important aspect of using vector graphics. And it's one that is actually pretty obvious once you understand how all this stuff works, but, well, I think it's kind of neat. At any rate, does anybody have an idea as to what that might be? Just to hazard a guess. I had it showing for a moment over in the corner, and then I hit it. Control-Shift-Q. No. Not that. Although, it was a nice guess. Let's back up a second. Usually that's, yeah, You're already aware of it, Abigail. It's not on a Chromebook. Okay, let's back up for a second. So vector graphics, what are they exactly? Any guesses? Nice, good to know. No idea what vector graphics are? There we go. Yeah, no, sorry, just what vector graphics are. Yeah, but you guys are right, pictures that overlap each other to make another picture, mathematical equations, stuff like that. They're pictures represented as equations. But the key thing there, raster graphics are graphics that are basically pixel art, but made from equations and stuff. Definitely on the right track there. The key thing is mathematical equations representing images. So again, if we go back to our example of y equals 2x plus 1, and this is our line, and it it draws that line and everything like that. Although it's it's not necessarily going to look like this, but whatever. Anyway, that would be kind of like a simplified example of what vector graphics are. Now, what is You guys have used stuff like this before in school, right? Like I feel like you guys have already gotten to this point. Yeah. So you know those problems where it's like, figure out what y is if x is a certain value. Like if we said that x is 2, you guys could very easily figure out what y is, especially with an equation like this. And because of that, you're able to graph the line yourself because you're able to figure out, okay, so if x is 2, then y has got to be 5, so we'll put a dot here, and if x is -1, then y is going to be 0, so nope, no, it's going to be -1. So we're going to put, how does that work? Yeah, negative 2 plus 1, -1, okay. So if x is -1, then y is also -1, so on and so forth. Like, you get the idea. And then you draw a line between the two and you have an idea of what the line would look like. Well, hold on to that concept for a minute. Because the next thing we're going to talk about is how vector graphics are good for laser cutting. So, okay, you can do some pretty cool stuff with laser cutters, right? Like this design that's cut out of the lampshade, that was something that was created as vector art first, potentially in Inkscape. Could have been Adobe Illustrator or something like that, who knows. But that was, at one point, vector art. And then it was converted into something that probably a PDF that or maybe they can use SVG files, who knows. Anyway, I keep wanting to call them STL files because of 3D printing. At any rate, we could use this design that we create in Inkscape in order to create something to laser cut with. STL. FTL is a good game though. This is another example of something that could have been created in Inkscape and then exported to a laser cutter to create like a headboard for this bed. And it has all of like the sort of tree branch kind of intersecting pieces on it and stuff like that. But it can all be cut out as one solid piece. Some more examples here. Over here we've got like a dress that's been cut very specifically. Over here we've got stuff that's been etched. So like all of this Fab Lab Tacoma thing, that's all been etched or burned into the wood using a laser. Just like the picture of this dude that's on wood. This house was cut out. All of this stuff. The Pyrex or whatever this is. So here's the key component of this, picture unrelated. Laser cutters, 3D printers, vinyl cutters, things like that. They work in a very specific way in order to ensure that there is, what am I trying to say here? That there is a high degree of precision and accuracy. And that way is basically, it's kind of like dead reckoning almost. So essentially, the way a laser cutter works, for instance, is, and this is not always the case, but in many cases. So here's our laser cutting head, most expertly drawn mural. Lasers come out of here. And this might be like our material that we're cutting. A computer is told to move the laser cutting head to a specific set of coordinates, one at a time. Now, granted, as far as my understanding is concerned, a lot of times, these can really only move in straight lines, so it can really only split the difference if it's told to go from here to here. it'll just move in a straight line, even if you wanted to do something like this. So the way around it is you give it many more points that trace that line. Because even if you have a whole bunch of straight lines, if those straight lines are small enough, let's go ahead and zoom way in and just draw a bunch of tiny little straight lines. Whoops. This is me actually drawing straight lines. But when I zoom out, it looks like a curved line. It looks like a very smoothly curved line. I know those were sort of inexpertly drawn, so it's not the best example, but by and large, the idea still stands. So it's told to move from one coordinate to another, right? Well, remember our example here of vector art? Yes, thank you, Jacob. And how we get this y equals 2x plus 1, blah, 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 blah. If you solve an equation, like if you plug in something for x, what is your answer? Well, your answer would be a y, correct? So you would have an x and a y. You'd have a set of coordinates. A laser cutter needs a set of coordinates, needs many sets of coordinates in order to make the cuts that they need. So you can see where I'm going with this. Vector art lends itself very well to things like laser cutters and final cutters and the like, because the way it's structured will very easily provide the data that you need for a laser cutter to do its thing. So yeah, there you go. And again, let me just try and yeah, that looks dumb. But, you know, I tried. At least we can say that. Complete the circle, and huzzah. Anyway, so you see where I'm going with this. Vector art lends itself very well to laser cutters because of the way that vector art is set up and the way that the things that laser cutters need in order for them to work properly. This is just a diagram of how a laser cutter works. It has a laser beam, and then it gets focused, and then it gets sent through some gas. And the gas and the laser together make a cut. And it looks pretty cool. I mean, really, when you think about it, I know I've said this before, but really when you think about it, the fact that we're using lasers to cut things nowadays, and it's just kind of a thing that you can do, and you can buy a laser cutter in your own house if you have the money. So you too can have lasers in your own house. It's kind of mind-blowing. Technology is advancing at an astonishing rate. And the stuff that I say is amazing today will eventually be pretty commonplace. And then you guys will see stuff and you'll go, wow, that's so incredible. And sure enough, give it enough time, that kind of stuff will start to become commonplace as well, and there will be something new on the horizon. Remember when computers were a big thing? Oh my gosh, it comes with, you know, a 300 megabyte hard drive. It's so big. Or it comes with, you know, I don't know, 1 meg of RAM. That's crazy. You mean you need at least 2 megs of RAM in order to run this game? That's impossible. You have to have a supercomputer. Getting so close to lightsabers. Well, lightsabers are trickier because the thing about lasers is they don't stop. unless they get reflected or they hit something that absorbs all the light. And lightsabers do stop. So like that's the sort of the fundamental problem we run into. Now the prevailing fan theories out there are that it's actually a plasma conduit contained within a magnetic field. So if you really want to get on your nerdy high horse when somebody talks about how lightsabers aren't possible, you can go, well, actually, or you could just say that, you know, the light's being held in place by the Force. Whatever. So really, 2 megabytes is better than your computer? 2 megabytes of RAM? You sure you don't mean gigabytes? Because I'm pretty sure you wouldn't be able to run this software on 2 megabytes of RAM. Oh, it's a toaster. Ah, that makes sense. Well, you can always run CS Source. The original, the best. Anyway. Good. There are laser cutters are actually more versatile than just being able to cut too. Like as you can see here in this little thing, you can cut. You can also not cut all the way through, and you can also not cut all the way through and do it over a large area. So you can do a cut, you can do an engrave, and you can do a raster. You can see we got a few different examples of that. Now, the raster in this case, I believe it's called a raster because they took it from a raster image. And so what it did is it took the color difference and etched out a design based on that. And that might be why it's called a raster, because that would make sense. And it still allows you to do pretty neat things like, you know, create etchings on a piece of wood, like in this example here. They took this guy's picture. Maybe this was the guy. He took his picture, and he went, hey, I'm going to turn this into a thing that's burned into wood. And he did that. And he was forever immortalized on a piece of wood. Always and forever. Although, you know, the fidelity doesn't come out exactly the same. As you can see, the original is much clearer than even the conversion in the middle part, and much clearer than the burned piece of wood on the right-hand side. Yeah, exactly. Now with vector, you can do a lot of cuts like this. Like this guy created a. That's pretty amazing. um, this person created a Ferris wheel, just with a whole bunch of different sides, and then they assembled all the sides together with glue, or maybe they're interlocking pieces. Although I guess my money's on glue or pins or something like that. And you know, it's got the little buckets, and when the Ferris wheel rotates, the buckets, you know, always point down, so it's like a regular Ferris wheel as opposed to those murder Ferris wheels that you always read about, the ones that dump you upside down and dump out all the people. It's not actually a thing. Although there are those Ferris wheels that have the cages enclosed on them, and then the Ferris wheel will go like, I can't remember what they're called. They're called like maybe cyclones or something. I can't remember. But then the cages also rotate in addition to the Ferris wheel rotating. Let me see if we can find one of those. I believe you're right, actually, yeah. There we go. The Scream Weaver. Wow. So it's kind of stuff like this, or like this. It's called the zipper. This one's called the zipper. So like it spins around the central axis here. So it spins around that way. This blue pen is really not easy to see. It spins around here. And then these move along the edges. The cages themselves spin. And it's pretty neat. Anyway, I'm getting wildly off track. Let's continue. You can engrave with vector. So as you can see here, they engraved this this scorpion design into a piece of wood. It's also important to note that you have a degree of what's the word I'm looking for? Control over the coloration of your engraving as well. As you can see here, here's a graph. The percentage power is basically how much power they're pumping into the laser at that point. And then the percentage speed is how basically either low speed all the way up to like max speed that the motors can move. So obviously the less power there is, the less it's going to burn into the wood, and the faster it's going, the less it's going to burn into the wood because it's spending less time on there. These are two very effective ways to reduce the amount of energy a given area of the wood takes. Increase one or the other, and you increase the darkness. Increase both of them, and you can very quickly get to the burning point of wood and set it on fire. So that's just so you know, in case you ever get a laser cutter in the future. Be sure that you're not, engraving at 100% power and 10% speed, because otherwise you'll set it on fire. Granted, everybody's laser cutters are going to be different, but that's just a general rule of thumb. Don't do that. Don't do that. Here's another example where basically a guy created a Day of the Dead sugar skull kind of a thing with a combination of etching and cutting. Basically cut out the different pieces of the skull, added etchings onto the front of the skull, and is able to assemble it, as a sort of a little 3D model. Now, granted, it looks a little awkward from that angle. I think it would have been better served to be, photographed from either directly onto the front or directly onto the side. But, oh, you got to head out, Liam? I was going to start talking about the project, but I'll put the video up on YouTube tonight, so you can go ahead and check it out then. But okay, I mean, if you have to, you have to. If you don't, you don't. Whatever. Either way. So yeah, we already talked about that. Let's go ahead, and I'm gonna show you guys what our project is. We already talked about raster to vector. That's already a thing. We already talked about most of that stuff. So let's see here. What we're going to do is we're going to take an existing design and we're going to add our own touch onto it. And then basically customize it. And then, at some point during lab, they'll get set up so that you can have them be laser cut, and then you can set up the board and have like a little beanbag toss game. So that should be interesting. At any rate, let's go ahead and download the original file. Let me go ahead and copy the link URL and paste it into the chat. And all you should have to do is just follow this link. Just like I did. It might take a minute to open up if you have slow internet like I do. Apparently it's slow internet. But you'll see, you'll see this design sitting on a gray background. In the upper right-hand corner, there is a downward-facing arrow with a line. That's the download button. Go ahead and click on that in order to download this design. And I do want everybody to do this, even if you can't get like Inkscape open or something like that right now. Just download it now so that you can work on it later. But it should download pretty quickly. Once that's done, go ahead and find it on your computer. And here we go. As you can see, I've already done this before. It might have the Inkscape icon already. Great. It might not, but we're still going to do this regardless. Just go ahead and right-click on it. Let it think for a second. If Open with Inkscape is your first option, fantastic. If not, go down to Open With and see if you can't select Inkscape for it. Alternatively, you can open up Inkscape and then open up the file while Inkscape is open. But this is just one that requires fewer steps. And the reason why I'm saying to do the right-click thing is because on a lot of computers, if you don't do that, if you just double-click on it, even if your default program is Inkscape, a lot of times it'll open it up in your default browser instead, so that you can just look at it in Chrome or Firefox or whatever, which is not ideal. So we want to make sure that we open it up in Inkscape. Then we're going to give Inkscape some time to figure its life out. There we go. I don't know why everything's defaulting to being up in the corner like that. But here it is. Here is our design. Now, you'll probably notice something if you zoom in. And I'm going to go ahead and zoom in to show you guys exactly what I'm talking about. It looks like everything that we're interested in is sitting on the canvas at the moment, right? That's not necessarily the case. As soon as I zoom in even a little bit, I start to see these faint gray lines appear off to the left. We've got like a couple of angled ones and then a couple of rectangular ones, one with like a cut taken out of it. The angled ones have a hole in them. There's one over here to the right. The ones to the left are necessary to build a basically what am I trying to say? I'm losing my words right now. So basically this, when all is said and done, this is meant to sit at an angle. So like just to give some perspective on it, there are the chevrons. There's the top bit of it. Like that. And then they got like little handles in them. Whoa. Got like little handles in them. But they're meant to be sort of the sides and back and front to it. so that it can stand up on its own. So, whatever you do, don't mess with these little thin gray lines over here. They're actually black lines when you zoom all the way in, but they're so thin that at most zoom levels that you're going to be using, they look like thin gray lines. But anyway, yeah, we're not interested in those. We're actually interested in customizing our own design, right? So we got a few things we can do. We can add pictures to it. We can add text to it. We can add, shapes to it, stuff like that. I'm gonna spend some time sort of customizing this in my own way. I'm gonna put some Carolina-related stuff on here. I'm basically gonna follow the slideshow. You guys don't have to do that. You guys can use whatever pictures and whatever you want. In fact, I encourage you to, so that it is very clearly yours. So here, let's see here. What I'm going to do is I'm going to go back to Chrome, and I'm going to do a Google search for UNC logo. And my internet's going to screw up. And I'm going to try that search again. And there we go. Now I'm going to go ahead and click on images. And now we're looking at a whole bunch of UNC logos. But I want to make sure that I have a vector image. I hope you guys remember how to do that, because that's what I'm going to do right now. I'm going to go up to the gear. I'm going to click on advanced search. Go down here to file type. I'm going to select SVG files. Once I hit advanced search, boom, all of these that pop up are going to be SVG files. So, and obviously we're going to have a whole bunch of them, like the Research Opportunities Initiative and this one for, UNC TV logo for 1979. UNC Charlotte, for some reason, a Snapchat ghost. This, I guess that's a vector RAM. That's not University of North Carolina. That's maybe University of Northern California. But that doesn't make any sense. Anyway, getting sidetracked. Whole point is, find something that you think is interesting or fitting. I'm gonna select. Go with this one, and we can verify when I clicked on View Image and it opened up in its own separate tab that it is an SVG file by looking at the file name up here, UNCTarHeels9.svg. Again, you're going to want to make sure that you have the rights to use an image in general. I'm going to right-click on this and select Save As so that I can download it to my computer. UNC Tar Heels 9.svg, let's call it little UNC symbol. Little UNC symbol.svg is downloaded. So now, I want to bring this into my Inkscape. How do you think I would do that? Yeah, it would be import. If there isn't anything good, can we use Inkscape to convert raster images? Yeah, just be sure that, it'll convert properly and it won't look all weird and wonky. But yeah, so yeah, we would use import, in fact, and not open. Open will open up your image in an entirely new file. Import will add your image to this file, and that's exactly what we want. We want to keep this one open, and we want to bring a new picture into it. If we don't do that, we select open, it'll basically close out this window right here and then open up a new window with our UNC logo on it and nothing else, or your picture or whatever. So I'm going to go to imports, and I'm going to find it. La 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 la. Little UNC symbol. And here it is right here. Hey, look at it, it's so little. It's so little. So here's our little logo. And this is what we're going to use. I think I'm just going to place it right here. Obviously, I can just do that, and I can resize it by holding down Control to keep the same proportions and align it and be done with it. But that's not exactly what I want to do. I mean, considering this is going to be aligned so that this end right here is the end that's pointing towards, you know, the person you're playing against, and this end right here is pointing towards you. Did it like pop up into a separate tab, or it's a Google message? Okay, but like, how did it pop up? Um, did it just take you to like a basic Google page instead of taking you to the? Yeah. All right, we'll try a different one then. Are you sure you're downloading an SVG? Yeah. No, sorry, Aiden. Jacob, yeah, just try and find a different image. It may be a case of your browser being, you know, overly cautious, or not. You know, I mean, it's better to be safe than sorry unless you really know like that the website is okay. Sorry, Aiden. Are you manually typing in .svg and it's telling you you can't save it like that? Well, anyway, so okay, so we want to align this properly. Whoops, I totally messed that up. Okay, and then in the address bar at the top of the page where you're looking at the picture, does it have .svg at the end? But it's not letting you save it as an SVG. What operating system are you using? Oh, Lord. Yeah, just be careful with that, Jacob. People can misinterpret it nowadays. Okay. Do you have like a little like drop down menu that's like a save as sort of option or a triangle next to where you give it the name. There are two Jacobs. No. Right-click on the picture and select Save As. Command S will save the whole page. Yeah. And that's why you're not able to save it as an SVG. Yeah, there are two Jacobs, one with a K and one without, with a C, I should say. One with a K and one with a C. Jacob with a C, I say you should be careful about how you use that because it could be misinterpreted. How to implement icon into that document, I can't get it to work. Import? Do you want to import something? Okay, but like what part of the step are you getting stuck on? Or what step are you getting stuck on? File, import, and that should bring it in. It still doesn't work in. I'm not entirely sure without looking at it. You're right-clicking on the picture itself, and it's save picture as, correct? Save image as, yeah. And it's not letting you save it as an SVG. It has to be a .png. Well, that's dumb. Okay. I guess just save it as a .png for now, and then we can fix it later. After you download it, you can right-click on it and get info, and you can change the extension in there. In the meantime, yes. So I want to rotate this. I'm sure you guys remember how to do that. Click on it twice to get the rotation arrows, and then what? Group everything. There we go. There. So now we can rotate it in 5-degree increments, and we can ensure at this point that the logo is 90 degrees. There, boom. Boom. Done. So there we go. Now we got our logo, which is aligned and rotated properly. Well, now we can add some text to it. So I can throw some text down. Boom. And let's make this, I don't know, this one. This one looks good. Why? And we can start typing now, any day now. There we go. Go. Set our font here. Make it super big. And we can use the cursor in order to move it. SVG is ideal because it will already be a vector file. Did you use import, Aiden? Or did you select open? Got to use import. Open will get rid of the old image. Import will bring in the second image, so you have both of them. So let's do our second bit here, heels. And we'll also give this an absurdly large font size. And we'll also give this a nice big blocky font to use. And then we can just drag it sort of into place as well. Now this looks a little bit awkward, so we can always rotate these. We can rotate them so that like they're facing outwards and they're readable that way. We can rotate them so that they're facing inwards. It's really whatever you feel like looks better. We can rotate them so that they're always facing downwards. Or we can do some sort of weird thing like that. Go Geels. It's really up to you. And in fact, I encourage you guys to spend some time. I encourage you guys to spend some time messing around with the different features of Inkscape and do something that feels a little bit like closer to what you'd like. You know, you can add some wonderful stars in. Look at that wonderful star. It's just a happy little star. And we will set it to be like sort of close to, that's not even remotely close, it's way too green. A little bit more gray. Yeah, stuff like this. Set it up so that it has a similar looking color. Obviously, the closer you can get it, the better. Doesn't matter what color the pictures are. No, not really. Not that I'm aware of, at least, because this is going to be etched out later on anyway, so it's going to be etched without color. It might matter in the sense that, like, you know, the laser cutter is going to interpret different colors as being different cuts and stuff like that. But, you know, Mr. Dubik can brief you on that when you get to that point if it ends up being the case. So for now, I wouldn't really sweat it too much. But yeah, so I mean, you can spend some time doing something like this. I encourage you guys to mess around with it and try and make it your own. Because again, at some point during lab in the coming weeks, you guys are probably going to have the opportunity to make something. Right now, I'm going to go ahead and do the poll questions, though, and I am going to leave it open for question and answer time, again, just so I have enough time to get prepared for my next class. Let me see here. It looks like it's all grouped together, so unfortunately, not really. Oh, there we go. Yeah. If you can ungroup everything, then yeah, sure. Just keep in mind that like it's gonna. I don't remember. Oh, it's called Aharoni, I guess. I suppose. Anyway, we're going to do the poll questions, and then we'll leave it open for question and answer time like we always do. And if you don't have any questions, you're more than welcome to head out for the weekend. Have a wonderful weekend, and we will see you on Monday. Anyway, first poll question incoming.